Because, see, for example, another student record and another student is living in one specific moment, entonces the recording is short, it's cut off. However, no. See, I noise, who's making noise? Limar. Okay, thank you. Okay. This is whiteboard, right? And suppose that you have polynomial function and degree m. Degree 4, degree 3, n is any natural number. So basically, this polynomial f of x has m zeros. Remember the idea for the zeros is the x in a set, or 0, is when the function is 0. But it's counted multiplier, o sea, multiplicity, sorry. Remember, multiplicity is when the one number is repeated, and also complex number, and complex. Immediately you see example to understand more clearly. I have one more idea. Idea number 1, idea number 2. And the polynomial function, that the coefficients are real number, we have, for example, maybe complex zeros, but the complex zero is coming by pair of conjugate. I want to explain in detail this idea. Complex number. Suppose that we have one complex number que es 3 plus 4i. The other complex number que es 0 also. We are talking about 0 is 3 minus 4i. And this idea is called a conjugate. I don't know if you remember in college algebra that idea. So basically, let me condense in the information. Suppose that we have one polynomial degree 4. So we have 4 zeros. Degree 4, we have 4 zeros. So one specific example I bring now today. Well, we have the 0 I investigate in the decimals, maybe. Y I saw que es 1 and 1. Repeated. Wow, why repeated? Because the multiplicity 2. You can indicate 1,1 or just 1 multiplicity 2, que es equivalent. Si es 3, 1, es multiplicity 3. Pero no. Es 2 real, 1, and 1 complex, que es minus 4i. This information is given. It's given. Somebody, not me, investigate que this polynomial contain 1,1 and negative 4 plus i, que es el complex. Automatically, you understand that we have another que 4 minus I, because I know very well that the complex inside the polynomial is coming by couple. So it's completely a contradiction to say, this polynomial have only one complex 0. No, or we have 2, or we have 4, or we have 6 even number, because they are coming by couple. I want to illustrate very well this idea. Entonces, in this example that I create for you, let me call example 1. I need to investigate the equation. Find the equation. This is a relatively easy problem, but this is important, no? In the Alex, you can see some questions similar to this. And it's easy, but it's a little bit long. But it's okay. So f of x is formed by x minus 1, because this is a 0, but the factor associated with this idea is x minus 1. No? Minus 1. Pero twice, entonces square. And multiplication 2 factor, this and this. Okay, the format for the factor is x minus something. Entonces, I copy, for example, x minus. Entonces, the first complex number is -4 plus I. Another bracket, actually bracket, because you know. Okay, no problem. Don't interrupt me, please. You incorporate late, no problem. I understand. X minus -4 minus I. Okay, so my polynomial function contains two real, que es 1, pero multiplicity 2. This is a hypothetical example I create for you to illustrate the idea, and two complex is coming like that. Okay, leave it like that? No. This is possible. The polynomial, however, is a polynomial is expressed. Yes, what is the phone number? No. Okay. I say again, Emily, pay attention, please. Okay. Okay, this is FOIL. You FOIL. Multiplication. Multiplication x minus 1 times itself. Okay, focus. This subject is hard. When I explain something, focus, pay attention. X times x is x squared, FOIL, minus x again, plus 1. Entonces, x squared minus 2x plus 1, when you combine like that. Entonces, x squared minus 2x plus 1. This part is this part. I want to dedicate that part. It's the complicated part. Bracket. And you FOIL also. X times x squared. X times this complex number is minus, parenthesis, minus 4 minus I, x. So I copy this, I copy that, and this minus in the front, no? Okay. Multiplication inner is minus, parenthesis, minus 4 plus I, x. And finally, negative and negative is plus. -4 plus I and -4 minus I. Okay? Let's do it. It's no big deal. Look like horrible, but no. Okay. I apply distributive property here. Distributive x squared plus 4x, because double minus, look, become positive x plus ix. Now here exactly the same, similar. Is plus 4x, double minus is positive, minus ix. And now multiplication this. Let me separate this to do auxiliary calculation. For that part gets a little bit complicated. You apply another FOIL inside here. -4 and -4 is 16. -4 and negative I is plus 4i. I times -4 is minus 4i, and positive I and negative I is minus I squared. This is cancelled, it's obvious. Positive 4 and negative 4i is gone. And stay alive only 16 ish. You don't pay attention, only you interchange telephone number. Wow. And negative I and I squared, I need to know that -1. A -1 and another -1 is +1. And this is 17. Okay, this answer is unbelievable. 17 plus 17. Okay, one more thing, I can do that. Well, this I is cancelled. And 4 plus 4 is 8. So far, it's x squared minus 2x plus 1, bracket, x squared plus ax plus 17. So far, everyone followed. I don't finish because the rest is, yeah, okay, Sebastian. The rest is piece okay, but it's too long also, no? Because we have trinomial, two trinomial, and then multiplication generate a 9 combination. 3 times 3 is 9. But okay, let's do it quickly because this is not super important. No? It's important to do for good. You multiply, for example, the first one times everything, bam, 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 like that. And you have x to the 4th power plus 8 x to the given power plus 17 x to the 2nd power. So I multiply this times this, and this. Now likewise, this times this, times this, and times this. Entonces es minus 2x cubed. Ahí está. Minus 16x squared. And 34, right? Minus 34x. Okay. So far we have 6. And the other is easy, is x squared, because it's 1, plus ax plus 17. Okay. How many? Let me count 1, 2, 3, 1, 2, 3, 1, 2, 3, 9. And we combine like that. Who is like? X to the 4th power. Okay. Let me highlight here. This is cubic, and no more cubic. Entonces es 6 x to the given power. Because 8 minus 2. And to the 2nd power is, using another color, 17, 16, and 1. Es 2, no? Es 2 because 17 minus 16 is 1, and 1 plus 1 is 2. Entonces 2 x to the 2nd power. What about linear? It's 34 and 8. This is 26. Very well. You're doing okay. Super good. But remember, I try to do slow down for the average students. No? It's minus 26, you say, x plus 17. And it's the final answer. Okay, the most important thing, this is none of this stupid algebra, is que one polynomial of the degree, suppose hypothetical 4, contain 4 zeros, including repetition. In this case, 1 is repeated, multiplicity 2, and the complex, que always in the problem is given incomplete, because they supposed you need to know that they are coming by pair of conjugate, See, it's given negative 4 plus I, you need to know automatically, conceptually, que es negative 4 minus I. Okay? Everything is clear?
Yes.
Okay, super. I feel that this class is good, but this is a little bit complicated because there are too much students. But okay, so you are quiet, you pay attention, you are doing a smart question, no stupid question. You know what is the stupid question? A stupid question, professor, I don't understand anything. Because you don't give me any clue what part I need to explain for you. So since you are a specific question, I appreciate it so much. Okay. She say, no, but we need more practice. Okay, I understand. How you practice? Doing the homework. What homework? The homework online. When you stop, you have the help of the Alejandro Martinez, or you have my help. My help online, my help, and the STEM lab tutor. Okay? And you are in the college, guy, and you need to ask for help. Okay? And the due date, if you don't do anything, I put 0 in the blackboard and in the story. May I erase the board? May I erase the board?
Yes.
Okay, super. Let's move on to the second example. But the second is different. It's more interesting. Is one polynomial is given. Suppose f of x is equal to x to the 4th power plus 5 x to the cubed power minus 2 x to the 2nd power minus 11x minus 6. So we study now one theorem, que is this rational zero theorem. This is a little bit complicated to understand because the theorem say que the rational zero theorem doesn't guarantee the existencelessness of the rational zero. But if they are exist, it's important because limit our search to find them. Remember, in the other class I explained using decimals. In this case, of course, you can use in decimal. Actually, when we finish, we see in decimal the solution. However, the zero factor theorem say that the collection of the rational, and the word rational indicates us fraction, or whole number, right? Rational. Zero is prediction, like plus and minus P over Q. And who is P and who is Q? In our example, P is 6. Who is 6? That's 6. I don't care the sign. The sign is not important. Do you see why? After. And Q is the first. Get 2. Okay? This is the prediction. These two numbers predict, that you see in this example, the potential rational zero in this polynomial. Entonces, what is the prediction, professor? Bueno, the prediction is plus or minus P divided by Q. In our specific example, is plus or minus 6 over 2. And you divide? No. You don't divide because you divide 3 and you lost possibility. You break it down 6 in different factors. And the factor of the 6 is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Oh, where come from this number, professor? Because 1 times 6 is 6, and 2 times 3 is 6. This is the several combinations that you have a factor of 6. And likewise, we are doing the combination in 2, que es plus or minus 1, comma, plus or minus 2. Okay, but I don't understand very well. Well, maybe in that moment you are doing a list. A list of what? A list of the rational zeros. For example, one possibility is you take 1 in the denominator. Wow. You take 1 in the denominator. Highlight. You take 1 in the denominator and divide by this, divide by this, divide by this, divide by this. Entonces, when it's 1, you know, it's invisible divisor. Entonces, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, divided by plus or minus 1, but plus or minus 1 is invisible, you know, plus or minus 1. Alejandro Martinez. Okay. Alejandro Martinez. Alejandro, do you want to say something or no? Change the scene. Okay, let's continue, right? Okay, the thing I try to explain is that the list is formed by the number in the top divided by 1 and the number in the bottom divided by 2. Okay, is in that case, look, comma, plus or minus 1/2. Where come from 1/2? 1/2 come from when you divide 1 divided by 2. Okay, and now 2 divided by 2 is 1, but 1 I have. 3 divided by 2, no, I don't have, it's 3/2. And 6 divided by 2 is 3, I have. And in total, I have now 1, 2, 3, 4, 5, and 6. Of course, plus or minus. Actually, it's 12 combination. And now it's a little bit consuming time. Try one by one synthetic division using that part. Okay? Pero no. We put in decimals and you identification who is this guy. I did that. I want to skip that part. Then, synthetic division of the polynomial is, remember the format for the synthetic division. Is, here, let me try it here. 5, -2, -11, and -6. And you try several combinations here, pero it's too long process. I know where's the answer. I know where's the answer. It is -1. -1, I take, for example, this guy, is -1. I try to do scientific division. Bring down to multiplication is -2, 3, multiplication is -3, is -5, multiplication is +5, and -11 plus 5 is 6, positive -6, and -6 times -1 is +6, remains the same. That means I discover that the factor x plus 1 belongs to the polynomial. Okay, this is a factor, and this is a 0. Factor and 0 is similar, no? It's x equals -1, que is exactly the number that I put here outside the sentence. Do you follow me? Of course, I don't finish because degree is 4. Degree is equal 4. I need to investigate. Yes. I did the job. You talk to me. Entonces now is I divided again by -1. Why, professor? Because I did my at home. I investigated word. Bring down 2. Multiplication is -2. Is 1. Multiplication is -1. Is -6. Multiplication is +6. 0 again. Wow. So x minus plus 1 again is a factor of the our polynomial. Anytime you perform scientific division, the degree of the polynomial, one of the quotient polynomial, is decreasing 1 time. So at the original, at the beginning, we had degree 4, and the first scientific division is degree 3, and the third scientific division is degree 2, and the fourth scientific division is degree 1, and we stop. Okay, therefore, you have -2. Okay, -2 is belong to the collection of the list. Okay, entonces bring down 2 without any operation. Multiplication is -4. And this is -3. And -3 times -2 is +6. Wow, fantastic. The factor x plus 2 again belong to the polynomial. Okay, is the 0 negative. And that's it. Stop, because this is a linear. How do you know it's linear? Because it's x to the 0 and x to the 1. So the factor, this last factor, is 2x minus 3. So what is the answer? Okay, it's 2x minus 3, the factor, and the 0 is, you put equal 0, so you get 3/2. And 3/2 also positive belong to the list. So this list give me a clue to start. However, in decimal you see more clear. So what is the answer? What is the answer? Well, the answer is the factorization. This problem, this polynomial function, is x plus 1 2 times square, this and this, chum, chum, x plus 2 1 time, that's linear, and 2x minus 2. Done. It's a factorization. And suppose que in some question ask me, so what is the zeros? What is the 0 of this polynomial? Well, it's x equals -1 multiplicity 2. And remember, when you have multiplicity 2, touch the axis. Because it's twice, you know. X equals -2 multiplicity 1, cross. And x equals 3/2 is 1.5, positive. 3/2, 1.5 multiplicity 1, again cross. And by the way, to have roughly idea how look like the end behavior of this polynomial, the end behavior expression is this part, is 2 x to the 4th power, coefficient is positive, exponent even, therefore the end behavior look like that. Boom, 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 like that. So it's like a right up and left up. No? And the Alex call it a little bit different. Call it rise and go up, something like that. But it's understandable. Okay. Rise and run. Okay, rise and run. Run is in that direction, similar to the slope. And rise is in that direction. But you need the specification right or left. No? This situation happen in the right part, in the left part. I don't know exactly. This is in that direction, in that direction. Okay. The name is not important. The important is the concept. To complete the picture of this example, I recommend you to see the decimals. Let me try, guys. Let me try. Let me share the screen with the decimals. Okay, and okay. Do you see or not? Do you see or not?
No.
No. Okay, I try again.
I just see like a background and you're like just there.
Yeah. Now don't worry. I switch again. Switching. Rational zero polynomial switching now. Try one more time. Do you see no? Si the answer is no, entonces I reload the page. No, okay, no problem. Something happened. Entonces stop sharing. And also sharing again. Start sharing. Now. Yes. Good. Something happened. Okay, entonces now, do you see the polynomial? Do you see the end behavior? Que es right up, left up, no? Because remember, the dominant is 2x to the 4th power. And the zero that we determined using scientific notation was -2 multiplicity 1 cross the axis, -1 touch the axis, and 1.5 que es 3/2 cross the axis. Super good? Super clear? Yes! I know. But I have another idea. Let me try to explain. Let me try to explain a new topic. No new, it's about polynomial again, but another approach to understand much better polynomial, right? I want to erase the board, guys. Okay? Que es Descartes rule. Descartes rule. Descartes. It's a rule. Descartes is the last name of the antique Greek mathematicians. Let me explain this rule using an example because it's a little bit complicated to explain verbally. But you understand the procedure. Suppose that one function, polynomial function, of course, is given. And is x to the 5th power. Wow. Minus 6x to the 4th power. Oh, yeah, sorry. You're right. Thank you 3 times. Okay. Black whiteboard. Sorry. Whiteboard. Okay, switch to. You see now? Descartes the rule. Okay, super. Thank you. Plus 12. Yes, super. No more yes, guys. 12x cubic minus 12 x squared plus 11 x minus 6. Okay. Say again, Professor. I can't. You can no. Reload or refresh your screen or your application. Our professor. No. Okay. Let's try again. Don't worry for that. Now, do you see? Same. Okay. Okay. Let me fix. Now, you don't need to click anything. I present the yes. Now yes. Okay. You don't need to click anything. You click, you change the environment. I don't like this. You change. You don't touch. Go to the grid view. Okay. Go to the grid view. To change this grid view. What is the grid view? Exactly. I don't know. And I don't care this. It's not important. I like this environment. Okay. Do you see whiteboard, right? Entonces, ready to understand. Now I see the word, Sebastian. Good. Okay, guys, stop. No more blah, 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 blah. Okay. Any comment you put in the chat? This is noise. Okay, entonces you compute one thing is called a P. P. Who is capital P? Well, capital P is the amount of change of sign that we have in the polynomial. And this is too easy to understand. Look, the first guy is x to the fifth power is positive, and it's a negative. One change of sign. Negative to positive, another change of sign. Positive to negative, another change of sign. Negative to positive, another change of sign. And positive to negative, another change of sign. How many change of sign we have? 1, 2, 3, 4, and 5. Equal 5. P equal 5. Guys, let me explain. Don't try. You are not teacher. The teacher is me. So don't make a noise. Blah, 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 blah. Okay. See, I ask you something, entonces you answer me. Otherwise, no. So P is 5. Entonces now Descartes discover one rule. And the rule say que the amount of positive zero in our polynomial, positive zeros, is or 5, or 3, or 1. Where come from 3 and 1? 5 and 5. Pick a view. Do you hear me well or no? Yes.
Yes.
Please focus it, attention. I explain one thing and it's no big deal, but you need your attentions. Entonces now, where come from 3 and 1? You're subtracting. So 5 minus 2 is 3. And 3 minus 2 is 1. And 1 minus 2, bueno, is negative 1, que have no sense. So you determine, okay, the story is, you determine how many chain of sign we have in the polynomial term. F5, chain of sign. So you subtracting 2 and subtracting 2 several times until you get positive number, no? So the idea is this polynomial, the Descartes rules say que contain or 5 or 3 or 1. Actually, I want to determine what is that, but so far this is the possibility we have. Okay, now what about the negative? Well, the negative is easy, it's similar, because you make a reflection of the polynomial. You replace x for negative x. Entonces it's relatively easy because the exponent is odd number, change but the exponent, que es even number, stays the same. Entonces es negative 5 x to the 5th power minus 6 x to the 4th power minus 12 x to the cubic power minus 12, wow, x to the 2nd power minus 11 x minus 6. And you define one capital M, que is the amount of change of sign que we have in the polynomial after the reflection. And you see get 0 because everything is negative. So no change of sign. No change of sign. That means that this polynomial have no negative zeros. However, I know that this polynomial, the degree is 5, and we expect 5 zeros. Entonces now, to understand a little bit much better this situation, I propose you conclude with the one table. Always the table is the same. You put the positive guy, positive zeros, negative zeros, complex, and total. Entonces, one possibility is possibility number 1. We have positive, 5 positive, is this. No negative. In total, we have 5, entonces no complex. Esa es one possibility. Another possibility is we have 3 positive 0. Of course, no negative 0 real. This is real, of course. And the complex, well, the complex maybe you have 2. Remember, the complex is coming by even number, right? By couple. The total is 5. And the last possibility is 1. Take 1 here. 1, 0. This is always 5 and 4. Okay. Now we investigate the possibility is true is that one. But how you investigate that, professor? Well, using the theorem we studied before. Okay. Suppose the rational 0 theorem, say plus or minus p divided by q. Who is p? P is 6. Who is q? Q is 1. Look, this is p and this is q. It's invisible. Now break it down. Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. It's the possibility of the factor of 6 and plus or minus 1. So my list is super easy. It's just plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Because I did the job at home, and I did one by one. No, this is lie. I put in decimals. And decimal immediately give me the solution. Right? However, I want to prove, professor, in the test, in the reading test, using synthetic division, the thing that you see in decimal. You see in them, I got it. But what? You prove me. Let's do in synthetic division. Okay, the original polynomial is 1, negative 6, 12, negative 12, 11, and negative 6. I copy that, the coefficients. Yeah, I try. I do synthetic division and 1. Using 1, okay, 1 belongs to this list is positive 1. This guy. Of course, I omit here in the lecture when they fail. How do you know they fail? When you have remained the non-zero here, entonces it's not the factor that belongs to the polynomial. But of course, in order to save time, you omit this idea. Bring down 1 without do any operation. Multiplication is 1. It's a negative 5. Multiplication this and this is negative 5. And this is 7. Subtraction. And 7 times 1 is 7. And this is negative 5. And multiplication this and this is -5. And this is positive 6. Because 11 minus 5. And it's a positive 6. Wow. Therefore, I prove mathematically that the factor x minus 1 belongs to the polynomial. This is a factor. And this is the zero. The zeros in plural, factors in plural. The zero is 1, x equals 1. It's the same number that you put here in the long center division. Let me try another. Suppose 2. Okay, bring down 1 without anything. Multiplication now. 2 times 1 is 2. It's a minus 3. Multiplication is minus 6. Is 1. Subtraction. Multiplication is 2. It's a minus 3. Multiplication is minus 6. Wow, amazing. The factor x minus 2 belongs to the polynomial and the 0 is 2. Finally, 3. Remember the prediction. Maybe we have 5, but I suppose that this prediction is a little bit stupid. The more clear or more sensitive for me is 3 positive. There is a reason they select these 3 positive. Okay. Let's try. So say 1 bring down. Multiplication is 3. Is 0. Wow. Multiplication is 0. Is 1. Multiplication is 3. And it's 0. Wow. And I discovered also that the factor x minus 3 belongs to the polynomial. Okay, the 0 is x equals positive. It's exactly the same Descartes rule predict here. So we remember our original polynomial degree is 5. We have 3 positive real, okay, 1, 2, 3. I create funny this example. And we expect 2 complex. This where come from the complex? Well, the complex comes from of the remainder part, the quotient part, sorry, is x to the 0, x to the 1, and x to the 7. Okay, remember degree 5 at the beginning. You perform 1 scientific division, it's reduced in 4, 3, and this is degree 2. So now the last factor is x squared plus 1. Look, x squared is missing the x and plus 1. Okay, of course, the 0 of that part is put equal to 0 and you solve for x. And -1, apply square root both sides. Wow, imaginary. Plus and minus. Okay, that factor, the 0 is 2 because it's quadratic, no? Okay, it's plus and minus I. And that's it. End the story. So basically, we have 4 factors. So the polynomial factorization is, doesn't matter the order, x minus 1 times x minus 2 times x minus 3 times x squared plus 1. This is a linear factor because degree is 1. Linear factor. This is linear, but this is not linear, it's quadratic. And this quadratic, when the solution is imaginary, it's called irreducible quadratic. Irreducible quadratic expression. And this is important, guys. Irreducible quadratic. Why irreducible? Because it's impossible the factorization in the real field. And the only possibility of the factorization is in the complex field. Pero you never using. Okay, by curiosity. Suppose that I want to express it, the factorization using only linear, not quadratic. So you break it down like that. 2 linear, and this is xx, but this is I and negative I. Positive I and negative I. Okay, but this is better. Okay, in the real field. Real field. Okay, super. Entonces, okay. See, the answer is factorization using only in the real field is this answer. Si the answer that they want to know is only use a linear factor, doesn't matter que es complex o no, entonces this answer. Linear. Remember, the word linear indicates degree 1. So if the exponent for the x is 1, 1, 1. This is not linear, this is quadratic. And the list of the zeros, suppose the list of the zeros of this polynomial is 1, 2, 3. Is the 3 real positive and plus or minus, is the 2 complex. Now you see clear on the table. Look at that. Look at that. This column is 3, is this 1, 2, 3, and 2 complex. In this case, actually, it's imaginary, no? It's pure imaginary, plus or minus. Do you understand very well? X minus 2 twice? No, x minus 2 not twice. X minus 2 is only one time. So one factor, look at the synthetic division. I divide by 1 was okay, 0 remaining. Divided by 2 was okay, 0 remaining. It's x minus 2, one time, x minus 1, one time. Divided by 3, x minus 3, 0 remainder again. No 2 times like this. This is 3, no 2, 3. Do you see, meter? Do you see or no? Super. Super. Let's do one more example. Oh no. Let me try to find one not too complicated. Let me see. I like this. It's no big deal. It's relative easy. Relative. And remember every tool that we have in this moment. We have synthetic division. We have the rational potential 0. So S plus or minus P divided by Q. It's another tool that we have to study today. And we have the Descartes rule. And we have decimals. Hello. What more you want? Okay? Let's move into another example. And that's it. Because the rest of the time we open new topic. Okay, one more. Okay, is the function polynomial is equal x to the 4th power plus x to the power minus x minus 1. Okay? Okay, so I recommend to investigate that. The same question, factorization, investigate si es real, si es positive, si es negative, Descartes rule, investigate plus or minus P divided by Q, and perform 1, 2, 3, the synthetic division that you need to break it down this in linear factor. Okay? Maybe in real field or in complex field. Okay, so let's move on. Let's start for the Descartes. And Descartes, remember P. Okay, P is the amount of change of sign. Well, this guy is positive, this guy is positive. No. This is the mnemonic device. When you change the sign, you put the weight like that. Don't change the sign, it's a flat. Okay? So in this case, positive, no. Oh, negative, and this is stay the same. Therefore, 1, P is 1. Now we have only one what? Only one positive 0. Real. Of course, we are talking about real. No imaginary. What about negative? Oh, negative is easy. You make a reflection. Reflection means change the x or replace x for negative x. And remember the even stays the same, but the unknown change. Because the point here actually is 1, no? Invisible 1, but it's odd number. And negative 1 stays. Okay, we analyze now M, okay, the change of sign and the reflection. and give me information about the negative real 0. Okay, this is change. Wow, the positive negative. Negative positive change. Oh, positive negative. And change again. How many change? 3 change. And remember, you subtracting 2. So 3 minus 2 is 1. And 1 minus 2 is negative 1. No good. Have no sense a negative number. It's stupid. Now we have 301 negative real 0. I don't know if it's 3 or if it's 1. So I am ready to make it the table que summarize this information. I know very well that the degree of my original polynomial is 4. Therefore, we expect in total 4 0. Maybe repeated or multiplicity or complex, I don't care. But you have, for example, the table positive, negative, complex, and total. And the row of total always is 4. No? 4. And so we have two possibilities. The possibility using 3 and the possibility using 1. P is always 1. The only thing that change is or 3 or 1. The negative. Look at that. Okay, entonces si es 1 plus 3 es 4, entonces no complex, 0 complex. And 1 plus 1 is 2, is 2 complex. Okay, I investigate after using the another idea. The correct answer is this. I anticipate this. The correct answer is that we discover 1 positive, 1 negative, and 2 complex. For example, the rational zero theorem don't give me any more clue because remember P divided by Q, plus or minus. Who is P? In this problem, is 1. And who is Q? Is 1. Push. So says plus or minus 1. So in our famous list, we have only 2 possibilities. 1 positive and 1 negative. Okay, actually, it's true. Both are this guy and this guy. But I need to prove mathematically. How? Centered division. Doing. Be careful with the centered division, guys, because when the polynomial something is missing, you put 0. Suppose. I propose you to guide me. You put an exponent, x to the 4th power, x to the 3rd power. This is not mandatory to do, but I like that. X to the 2nd power, x to the 1 power, and x to the 0 power. Okay. The coefficients in x to the 4th power is so because 1. The coefficients in x to the 0 is so because 1. The coefficients in x to the 0 is amazing. I don't see any term that contains x squared. A negative 1 and negative 1. This is important in the centered division. The organization in the column is extremely important. Of course, you don't need to write. This is completely irrelevant. Okay, and you try, for example, 1 or negative 1. I try in my paper 1. Bring down 1 without doing any operation. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 2 plus 0 is 2. 2 times 1 is 2. This is 1, and 1 times negative 1 is 1 positive. 0 remainder. And when you have 0 remainder, it's because maybe you say, well, all we have in professor is no, because I know where the answer can work. The other answer you put here, you put another number, is no 0 remainder. Entonces no es a factor. Therefore, the factor is, let me write like that. Factor and zeros. Factors and zeros. Well, actually, I anticipate that the 0 is this. But I don't know, I need to verify. The factor is x minus 1, and the 0 is x equals positive. Again, negative 1, or 1 again, repetition, I don't know. But I know where the answer is, so no repeat. Bring down 1, 1 times negative 1 is negative 1, 2 minus 1 is 1, multiplication is negative 1, and 2 minus 1 is 1, and 1 times -1 is -1, 0 again. Super. Now is x plus 1, the factor, and the 0 is x equal -1. Ooh, exactly the same. We predict a little bit, you know, not too strong, but we predict according to the zero, rational zero is factor. Entonces, si is this combination, we have one positive 0, we have one negative 0, and we have two complex. I suppose that this polynomial, actually is trinomial, x to the 0, x to the 1, and x to the second, que es x to the second plus x plus 1, is another irreducible quadratic. Que the 0, I have no idea, but I want to find in few seconds. Okay, so now, one possibility of the answer for this problem is the factorization professor of this polynomial is x minus 1, x plus 1, and x squared plus x plus 1. This is the factorization, include a linear, quadratic, irreducible, and the real field. So suppose I want to do in the complex field, well, I put equal to 0. Is the only possibility that we have to solve this is the quadratic equation. And the quadratic equation A is 1, B is 1, C is 1, and plugging in our famous quadratic formula. Everything is 1. So it's -1 plus and minus square root 1 squared minus 4 times 1 times 1, because everything is 1. A is 1, B is 1, and C is 1, divided by 2 times 1. Doing the operation inside the radical first. According to the order of operations, this is 1, because 1 squared is 1 minus 4 is -3. So actually is square root -3, que es imaginario que es I square root positive 3. Okay, almost, I finish, The answer of the complex part is -1 plus and minus I radical 3 divided by 2. Yeah, I prefer separate these two in two parts because I consider this the real part, then I consider this the imaginary. Suppose I want, well, professor, what are the zeros of this polynomial? Well, the 0 is, okay, I have here, look. Oh. Let me erase that part. The 0 are, look. 1, -1, real. And we detecting a complex. And the complex, this guy. The complex is -1/2 plus or minus I radical 3. I prefer this notation using plus or minus, but you know very well that this is equivalent to say -1/2 plus I radical 3 over 2 and -1/2 minus I radical 3. Actually, the 0 of this polynomial is this guy, 1, -1 real, and this guy gets complex. Okay, and the complex normally we express it in standard form, and the standard form of the complex number is the real part plus I, the imaginary. Okay, almost, I finished. Then, suppose I want to factorization in the complex field. Okay. Entonces now I'm using only linear, no quadratic, irreducible anymore. No. Is x minus 1, x plus 1. Entonces now here we have bracket, I like bracket, is x minus paréntesis -1/2 plus I radical 3 over 2, close the bracket, another bracket, x minus -1/2 again minus I radical 3. Guys, you can leave it like that. Or some picky student, well, okay, I cannot do distribute the property? You can, of course. Entonces es x plus 1/2 minus I radical 3 over 2. And this is x plus 1/2 plus I radical 3. It's another possibility of the factorization. Two complex, linear, and two linear also, pero real. Wow, amazing. You understand very well or no? Complicated. I promise. Yes, I promise, guys. Que in the review package, we go over again to this in detail, reinforcing, repeat. For the moment, my recommendation is you focus on the homework. Okay, focus on the homework every week. We are doing with the Alejandro Martinez. It's waiting for you this time. You join to the WhatsApp group. Or me, you know, it's Tuesday and Friday, 1 p.m. to 4 p.m. You are my student, so therefore you are VIP person. And Alejandro report to me the students that are doing this job attendance, and I give you extra point. How many points? Well, depending on attendance. See, if you are doing every week, systematic 2 times, 10 points. In every test. If you are doing only 1 time, 5 points. If you are doing 0 times, 0 points. Got it? One more thing I forgot, and you take advantage. Listen to me, super careful. You do the homework every week. Yeah, every week I send. Okay. What is the idea? Listen. You have 4 homework. This in this chapter. Approximate duration is not exactly 1 month, but this. So now, any week I send to Alejandro Martinez the PDF, que is very similar to the problem that you are doing in Alex. Okay, it's similar. I repeat, similar objective set procedure, but different. Every student have completely different. I'm explain one example, and you guide for this example, and you try to do by yourself your own example. Correct? Okay. So now we finish polynomial. No more thing about polynomial. Silvana Rodriguez. He said yes. Okay, entonces we study another thing, que es rational function. Rational functions. Okay, rational function is a little bit more complicated. Polynomial is easy. Rational function, complicated. And what is that definition? Well, rational function, let me call R the rational function, a division to polynomial, PQ. I put example now, I investigate the domain, I investigate the factory form, either way. But basically is division to polynomial. Restriction, no? The restriction is Q, never 0. Because it's totally illegal, division by 0. Division by 0 is undefined. And P and Q both are polynomial. Exactly the same we studied before. Okay, so now I want to study different example. In this example, you analyze different things. You analyze function, is given. Rational function, of course, we are talking about this. We study also factory form. Well, okay, well, it's possible, no? Sometimes no, sometimes yes. Basically, the idea is do factorization the top part and do factorization the bottom. Okay, suppose it's easy. And domain. By the way, I don't say maybe explicitly that the domain for any polynomial is all real number. One polynomial alone have no restriction. It's all real number. This is elementary idea. However, the rational function no, because you have restriction against this. Okay, let's start. Example 1. Boom, boom, boom. Of the rational function. Suppose we start with the elementary kindergarten example. F of x equals 1 over x. Reciprocal function. Okay, is rational function, professor? Oh, yes. Because on the top you have 1. And you can interpret it like a one polynomial degree 0. Degree 0. And x in the bottom is degree 1. Makes sense, right? This is one super elementary rational function, but it's okay. It's actually it's rational. Okay, now factor 4, we cannot do anything because 1 is 1 and x is x. So they are perfect coincidence, factor 4 and function, because we cannot factorization this expression. Well, you can, you see in a few minutes, in a few seconds, it's possible. The one domain, the domain is all real number except 0. 0 is the bad guy, because when you plug it in 0, or you try to plug it in 0, let's see what happens. 1 over 0 undefined. Okay, that's it. Okay, the domain is all real number such that no 0. This is one easy way to write this domain. Another way is, in the interval notation. Let me try to understand interval notation. Interval notation is, this is the all real number line. This is the positive infinity. This is a negative infinity. And the domain for that function is all real number except 0. 0, no. 0 is open here. And the rest is domain. You can plug in any number, but 0, no. This is 0. Therefore, 0 we have a whole. Therefore, the domain is 2 pieces. From negative infinity, comma 0, no include 0. And remember the notation no include 0 is parenthesis. Si include 0 is no parenthesis, es bracket. Pero no, bracket no, because do not include 0. It's parenthesis. Okay? And the second piece, parenthesis, is from 0 to infinity. And why not connecting this using that symbol to indicate unit? Because the domain is the interval, actually is no one, it's 2 pieces, and you connect them by unit, right? Everyone follow me so far, or no? You say yes. This is my first kindergarten example. I want to complicate your life. Okay, no more yes. I understand. Suppose example 2, get the name of the function is g. And g we have in the top monomial. So actually monomial is a particular example of the polynomial, degree 2. And in the bottom we have trinomial, x squared minus 5x plus 6. Okay, super. Okay, let me make it super. And the factorial form of g is easy. You factorization, well, on the top we cannot do anything because it's just monomial. But in the bottom, yes, a trinomial, you break it down in 2 parentheses, 2 binomial, x, and the combination of the word is 3 and 2. 3 times 2, 3 times 2 is 6, and somehow 3 plus 2 is 5, and both negative. It's important, guys, que you are familiar with the factorization. This is factorization is intermediate algebra. This is pre-calculus. Okay? Therefore, investigate the domain when we have two restrictions. The restriction is x not 3 and x not 3. Because when you plug in 3 here, 3 minus 3 is 0. Suppose that you replace x for 3, g and 3. 5 times 3 squared is 9. 9 times 5 is 45. Okay, no problem. 3 minus 3 is 0. 3 minus 2 is 1. Okay, but 0 times 1 is 0. Hello, this is 45 divided by 0 undefined again. But we have 2 undefined, and 2 happens similar situation. 2 minus 2 is 0. So what is the domain? Well, the domain is all real number except 3 and negative 2. Okay. Therefore, you write like that. Let me erase to put in elegant way. Domain is open this because I want to using this is set builder notation. And this is interval notation. You need to be aware to represent in set builder notation or in interval notation, because I don't know exactly in the test or in the lab online what they want. Not 3 and not 2. It's a bad guy. Well, and this is super easy because this is my famous all real number line. Infinity, negative infinity, and we have 2 holes. 1 hole and 2. This is 0. This is 1. This is 2, and 1 hole and 3. Actually, my domain is this interval. Okay, to 2, stop and 2. It's a 3, and between 2 and 3 we have an infinity real number. 2.1, 2.2, 2. Whatever, and after that. So that the domain expressed in interval notation contains 3 pieces from negative infinity, from negative infinity, comma 2, union, 2, 3, union, 3, 3. Okay, this is the set of the value that when you plug it in the function, no problem, no undefined, and 2 and 3, bad guy, undefined. Everyone follow me? Okay. Now number 3. Okay, number 3 now. Number 3 is another rational function. Okay, the name is h. It is x plus 3 divided by x squared by 4. Okay, this is given like that. However, I want to find the factorial form of this example 3. One on the top is just binomial, leave it like that. But in the bottom, identification is irreducible quadratic expression. How you can identify? Well, you can identify in different ways. Suppose that you put equal to 0, because I want to investigate the undefined, the domain. You solve for x. By square root both sides. Plus or minus 2i. Because you know very well that when you have negative number inside the square root, it's imaginary. Okay, entonces this is categorized like this polynomial is irreducible quadratic. Okay, we can break it down. Yeah, we can, but in complex. But in this part, no, never using complex. It's impossible, the factorization, at least in the real field. And the domain is obvious que es all real number. You put in English all real numbers or, and that notation is from negative infinity to positive. Guys, everything in algebra, okay, you try to find something, and you set out the equation. You see in this chapter, in this topic specifically, several times, you want to find something, and you set out the equation, equal to 0 or no, and the answer is imaginary is because do not exist in the real field. Okay? So now we have no restriction. I try to investigate restriction. You put denominator equal to 0, like this. Look. But when I investigate that, the answer is imaginary or complex. Therefore, we have no restriction in the real field. And number 4 is very, very important example. It's P of x is the name. S equal x squared minus 11x plus 30 divided by x squared minus 9x plus 18. 3 plus 18. Okay? I have no idea, but I try to do my best in factorization. It's trinomial, binomial, something like that. Open 4 parentheses, 2 for the top, 2 for the bottom. And the combination is 2 because 6 and 5, because 6 times 5 is 30, and somehow 6 plus 5 is 11, and the sign is negative. And the bottom part is 6 and 3. 6 and 3. Because 6 times 3 is 18, and 6 plus 3 is 9. And the sign is also negative. But one interesting situation happened. You have here one factor gets cancelled out. Look at that. This and this say goodbye. And stay. X minus 5 divided by x minus 2. Okay, so this expression, okay, this is the part gets complicated to understand for the student. This expression gets the given at the beginning is equivalent to this, except, and no 6. Because in 6 we have a whole. Okay, a whole. There are two kinds of to be undefined. To be undefined because in the point is a whole, and the representation for the whole is something like that, a whole, or asymptote. Okay, asymptote, vertical asymptote, more specific. It's a vertical line, and the curve approach but never touch. The other example that we see, number 2, for example, this is asymptote. Because there's a 0 of the denominator. But in this case, no. So basically, you have whole in 6. In 3, we have asymptote. I promise you see after that in detail the difference between whole and asymptote. But it's easy to understand because your factorization, no problem. It's the first step, always, to analyze this kind of function. The factor gets cancelled out is a whole, and the factor can stay alive in the bottom is the asymptote. Okay, and this expression is equivalent to this, but not 100%. I suppose it's 99.9%, because it's valid perfectly and it's easy to manipulate down the region like horrible, but not in 6. In 6 is undefined. In 6 no is undefined because you can plug in 6 here and nothing happened. Okay, so now the idea for the whole is to be undefined. Entonces now what is the domain, professor? Well, the domain is all real number. Domain of the number 4, no? Is all real number except 6 and 3. But what's the problem? It's similar to this, no? Because in the number 2 problem, both are asymptote. And in this, no. We have a whole in 6, and we have the asymptote in 3. How do you know que es whole or es asymptote? The factor gets canceled out in the top and the bottom is a whole. Otherwise, no. Otherwise, it's asymptote. Super clear? Super clear? Okay. Okay, entonces, okay, little by little, we approach it to the goal. Look, now I want to explain a little bit, not too in super detail, the vertical asymptote. How do you recognize? How do you recognize? I can erase the board. Well, remember, everything is recording. I posted the video today in the YouTube, and you're watching the lecture the time you want. By the way, I forgot something important. Something important. If you subscribe, and my YouTube channel gets super easy, you click in the red button, subscribe, in my account, you have 5 points extra in every test. Well, not in every written test. For every reading test.
So it's 10 points if we do the homework plus 5 points for every written test.
Exactly.
So it's 15 points. If you do the...
Take advantage.
Oh, wow.
Take advantage. And you
so
get
we have to subscribe on every video you make before the test.
No. In my YouTube channel, one time, and that's it. Yeah, adding 5 points. 5 points in the reading test. We have 4. Actually, it's 20.
Okay, all right, perfect. Thank you so much.
Okay, well, let me explain one more thing. What is the name of this? The notification. And YouTube is no good. So I don't trust in the notification of the YouTube. Sometimes good, sometimes not good. So you don't worry. When you have time, not now, you subscribe my YouTube channel and you send me email with the screenshot for the I put in the roster, no? In the roster, no. I have my private spreadsheet Excel in which I put everything, every point you get in the subject. I put everything. In the blackboard, no. In the blackboard, you see only the total result. Okay. Suppose that you get 100, and that is one written test, and you see, wow, it's not 100, it's 115. Where come from 115? Well, it's 10 points because you are doing the homework. What do you say? Miami-Dade College student? No. This is my channel, my name. Okay, when you watching the video, you see subscribe in the channel. You press the button one time and that's it. You have 20 points, totally free for the entire semester. Do you understand the idea or no? Don't worry. I explain again another day. Please see me. Yeah. Lizzie Emily stay with me 2 times. So you don't need to subscribe 2 times. Only 1 time is enough. Automatically, if you take with me 2 subjects, this point is transferred directly to the other subject. Of course, you remind me, please, okay? You will send me my professor. I did a subscription. I subscribe. Do you understand very well or no? Take advantage, guys. Take advantage. Okay, so we are talking about vertical asymptote. Remember, vertical asymptote is the factor that stay alive in the bottom and to be undefined the function, no whole, vertical asymptote. But we have 4 kinds of vertical asymptote. Normally the vertical asymptote we can see not today in Desmos when you're discussing in detail that part. It's represented using dollar line. Dollar line. In one specific point, we find the asymptote, dollar line. But we have 2 kinds, 4 kinds. For example, you have this situation. This is the function. Suppose. Oh, this is the function. Oh, this is a function. Oh, this is a function. And we have 4 possibilities. This continues forever. Sometimes you extend the idea using arrow. That indicates it continues forever in that direction. How do you know? How do you know that? Well, you know you put in decimal, no? And you see. But one possibility, mathematical, with that computer, is you get that value, the asymptote value. Let me use another code. You get the asymptote value, is that value, x equal a, 2, 3, 4, I don't know, depending on the problem, x equal a, x equal a, and x equal a. I determine at x equal a, we have vertical asymptote. Now, if you want to see what is the shape of this curve, well, you evaluate the function is given, the function. You evaluate a little bit before and after the asymptote. Like that. Bam, 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 bam. Entonces, I call A plus and A minus. No, this plus and this minus don't indicate negative and positive. No, this is a little bit after. Suppose que x is 2. And what mean 2 plus? 2 plus mean 2.1, 2.2, or 3. Pero close to the asymptote. You evaluate a function at A plus. In this example is negative 1. Look at that. The y value is negative. You see? And the function evaluate in A minus, is before is positive. They understand very well that the behaviors look like that. This corresponding with that behavior. So you evaluate the function before and after, and both are positive. This is this behavior. So you evaluate the function before and after, and you see that after is positive, but before is negative. This is that behavior. And see both are negative, and then it's the last behavior. Super easy, eh? Super easy to understand, right? Yes or no? Let's do it one elementary kindergarten example. Super elementary. And the complicated for next week. And that's it, end the story. When we have 10 minutes, so let's do in one elementary and another non-elementary. Okay. 2 examples, and that's it. I promise. Okay, suppose example 1 about the vertical asymptote. Suppose investigate that function. Okay, it's 2 over x minus 3. Okay, this is rational. Why is rational? Because the division to polynomial. The polynomial at the top is degree 0 because have no x, it's just a constant, and the polynomial at the bottom is degree 1. Super. Now we have no possibilities of simplification, nothing to say. That means that we have no holes. No hole. This function have no hole. It's all. Always when you can. Simplify eso. Ajá, entonces nada, pero básica, yes, we have verified asymptote. And the verified asymptote is you take the polynomial and the bottom, que es q, so the formula is q of x equals 0. Who is q in our specific example? X minus 3 equals 0. Therefore, x equals 3. Bam. Therefore, I know, without decimals, in 3, 1, 2, 3, we have 1, this 3, 1 very fast. Okay, let me try to do better. 3, 1, 2, 3, and 3 we have back. Okay, but I know, okay, we have 4 kinds of behavior. I need to understand. Okay, no problem. I see. You evaluate before and after. You evaluate 4, and you evaluate 2. Okay, before and after 3. So 2 plus is 4. 2 minus is 2. 3 minus, sorry, is 2. And you evaluate, that's it. 2 over 4 minus 3 is 2 over 1 is 2. And the point is the point, 4, 2. This is 4, this is 3, this is 4, 2. 1, 2, in y-axis. Okay. This is the point. Entonces I suppose que at least that part look like that. I don't know exactly what happened here. After I need to investigate another thing. But in 2, we have 2 over 2 minus 3. And 2 minus 3 is negative 1. Entonces negative 1. And the point is 2 comma negative. And 2 comma negative 2 is 1, 2, negative. Right. Now, I understand a little bit roughly. In my horizontal, my vertical asymptote, sorry, look like that. Similar to that behavior. Look. You understand the idea? Similar to this. Yeah, I can do a demo super easy. Do you want to do the demos or no? Because demo is a little bit complicated because she say yes, please. Demo is a little bit complicated because I need to. Okay, let's do it. Why not? Let's do it. Let me open demo, but one totally new. Let's go. New graphic. Let me share the screen and you let me know if you see or not. Boom. Boom. Do you see or not yet? Do you see or not? Super. Okay, so you put f of x, and this guy, you put f of x if you want. Yeah, f of x. Look, let me show you in detail this. F of x. Or y, either way. I prefer f of x. Let me explain why. I need to understand reason. F of x equals something. Equal, our example kindergarten is 2 over, right? 2 over 2 division. No, it's a parenthesis. It's x minus 3, no? X minus 3. X minus 3. Boom. And you see clear like a water. Okay, at x equal 3, wow, we have the vertical asymptote. But the vertical asymptote always, when you send me the graph using decimal and the text attachment, I would like you change the color to black color because the asymptote always is black and the other line. Boom, like that. Okay? So now, what is the reason I using function notation? Well, professor, because I want to evaluate before and after, que was in 4 and 2. Then you put f of x, so you evaluate f. Well, no. Much better is you open the parentheses and you put the point, que is 4 comma, and this is super useful, not in this elementary example, but in other more complicated, you use it like a calculator. F, evaluate for. And you get the point, and you put a label for command. Likewise, in the same line, if you want, you separate by comma, the next point is 2, negative 2, no? 2, pero bueno, no. Es 2, something, 2, the function. I use function notation. I take advantage of the calculator and 2. Oh, it's 2, negative 2. And this example is super elementary. You can do by hand, but no. It's a horrible fraction or horrible decimal. Entonces, using function notation, you take advantage of the calculator of the decimals. Super cool. Super cool. We are the best in Miami-Dade College, or no? Do you see my face? Do you see my face sitting here, no? Look at that. Okay, we finished today. Bye-bye. We continue. Have a nice day.
Have a good afternoon.
Okay, good afternoon.
Thank you, Professor. Great.
Pleasure, anytime. Take advantage of our help.
Professor, I have a question.
Go ahead.
So for Alex, I've used it before, and I know there's like a financial aid code that we can use for like students who haven't received their financial aid yet to buy Alex. Do you have it?
Well, I don't have information about that, but if you need financial aid and you have financial aid and the financial aid is not coming so far, we can wait it specifically for you. I extending a little bit 1 week more, right? And you let me know. Keep informed. And the class online is super important. The communication is you email me and explain me in detail. Okay? So you don't explain, I don't know. You put zeros. You don't do this. But no. See, you explain me. I understand. Because I waited for you. When you finish. But this is the first week is complicated. Do you understand?
Yeah. Thank you.
Nature. Bueno, bye. I leave it.